Hi everyone in Algebra 2B. Today we're going to be going over your questions on lesson 108 part 2. And we are going to start on number 16. So if I look at number 16 and I were to add the top two equations together, notice that the y's are actually going to cancel because one is negative and one is positive. And that is exactly what we want. So that's going to give me 4x minus 2z is equal to 10. Now, if I had the bottom two equations, the y's are going to cancel again. So I get 5x plus 2z equals 17. Now, what you should recognize is with these two equations, I actually can do elimination right away. And I can add the two equations canceling out the z's, and you get 9x is equal to 27. So when you divide by 9, we get x is equal to 3. Once you know what x is equal to, I can take that x and I can plug it into either one of these equations here to solve for z. So I'm going to use the bottom equation. So it's going to be 5 times 3 plus 2z equals 17. 5 times 3 is 15. So when I move it to the other side, I'm going to subtract it. So I have 2z equals 2. Therefore, z is equal to 1. And lastly, I need to solve for what y is equal to. And I'm going to take both of my x and my y, and plug it into one of the three equations. Let's just pick the middle one. So I'm going to do 3 times 3 plus y plus 1 equals 12. Well, it's 3 times 3 is 9 plus 1 is 10. So when I move it to the other side, I'm going to subtract 10, which means that y is equal to 2. Now looking at number 17, I have to solve my equation for y. So I'm going to have negative 3y is greater than or equal to positive x minus 9. Divide everything by negative 3, but when you do that, don't forget you have to flip the sign. So that would be y is less than or equal to negative 1/3 x plus 3. Now this one here is going to be a solid line, and we're going to shade everything below this line. For this line right here, it's going to be a dotted line because there's no equal sign. And because y is less than, it's going to shade below. So this one, the y-intercept is actually 0 because it doesn't have a plus b. And then the slope is rise over run would be up to over 1. And up to over 1. So again, this is a dotted line. That looks a little bit crooked, but should look something like that. Now my second line is going to cross at positive 3, but the slope is down 1/3. Or you could always do up 1 to the left 3. And this one's going to be a solid line. Like that. So now comes the shading. So I need to shade everything below the dotted line. So below the dotted line would be all of this region. Okay. And then if I shade everything below my solid line, that would be everything in this region. Which means that your answer is going to be the section that's covered by both, which would be the section that's under both of your lines. So it would be this section right here. And that's lesson 17. Now number 18. I to the third is equal to negative I. So that would be two negatives would make that a positive I. And then square root of negative 2 times square root of 2 would be square root of 4I squared. And square root of 4 would be just 2. But I squared is negative 1. I squared is equal to negative 1, or sorry, negative 1, not I. Negative 1 minus 2I. So really what I have is positive I plus 2 over negative 1 minus 2I. And I'm going to multiply top and bottom by negative 1 plus 2I. So I just flipped one of the signs. So I times negative 1 would be negative I. I times 2I would be 2I squared. And I squared is equal to negative 1. 2 times negative 1 would be negative 2. 2 times 2I would be 4I. In my denominator, negative 1 times negative 1 is positive 1. Negative 1 times 2I would be negative 2I. Negative 2I times negative 1 would be plus 2I. And negative 2I times plus 2I would be negative 4I squared, which is equal to negative 1. So in the numerator, I have negative 2 plus negative 2 would be negative 4. And then negative I plus 4 would be plus 3I over 1 plus 4 is 5. Now looking at number 19, same idea, but we're going to multiply top and bottom by 2 minus root 5. And you do need to multiply this out fully. So 4 times 2 is going to be 8. 4 times negative root 5 would be negative 4 root 5. Oops. 3 root 5 times 2 would be 6 root 5. And then 3 root 5 times negative root 5 would be negative 3 times 5. Over 2 times 2, which is 4. 2 times negative root 5 would be negative 2 root 5. Root 5 times 2 would be positive 2 root 5. And positive root 5 times negative root 5 would be negative 5. The 2 root 5s would cancel. Then I would have 8 minus 15 in the top would be negative 7. 6 root 5 plus minus 4 root 5 would be plus 2 root 5. And then 4 minus 5 is actually negative 1. So I can actually distribute that negative 1 into the numerator, making that 7 minus 2 square root 5. Now for number 20, what I'm going to do is I'm going to change this from this format into exponential format by making it into brackets. So this is going to be bracket 9 parentheses 3 to the power of 1/3, the whole thing to the power of 1/6. I'm going to change 9 so that it has a base of 3. So that would be 3 squared, 3 to the 1/3, the whole thing to the 1/6. You're going to distribute, which would give you 3 to the 2/6, which is 1/3, and then 3 to the 1/18. Common denominator was 18, so I have 3 to the 7 over 18. Now for number 21, I'm going to try and squeeze this problem in here. So I need to multiply top and bottom by the square root of 5 and the square root of 3. and simplify the square to 60, which would be 2 and 30, then 2 and 15. So this simplifies to 5 root 15 over 5, and the 5s would actually cancel. And then 2 root 15 over 3 minus 2 root 15 over 1. So the common denominator looks like it's going to be 3. So I just need to multiply this by 3, this by 3. So I have 3 root 15 plus 2 root 15 minus 6 root 15 would be negative root 15 over 3. So 3 plus 2 is 5, minus 6 would be negative 1. Now looking at number 22, so for this one, what I'm going to do is I recognize that r is positive, u is negative, meaning that it goes to the right of the origin and then goes down, which puts us in quadrant 4. So this would be 4, this would be 14, this would be your hypotenuse, this is your angle. So hypotenuse is just Pythagorean theorem, so 14 squared plus 4 squared. Fourteen squared is 196 plus 16, which is going to be 212. So 2 square root 53, I think, is what you get. Now you use inverse tangent to solve for the angle and do opposite over adjacent. In your calculator, that's 14 divided by 4 equals, and then second tangent gives me an angle of 74.05, but I do need to recognize that it's in quadrant 4, so I'm going to subtract that from 360. So your answer is going to be 2 square root 53. Your angle is going to be 285.95 degrees. So Pythagorean theorem and inverse tangent for number 22. Number 23, all I have to do is convert this from feet per second to miles per hour. So the first thing we're going to do is convert this to miles. So that's 1 mile in the numerator, and then 5,280 feet in the denominator. Seconds to hours, so there's 60 seconds in 1 minute, and then 60 minutes in 1 hour. So your answer would be 40 times 60 squared over 5,280, and that is miles per hour. Now number 24 is tricky because you probably needed to remember what the distance formula was. So the distance formula is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So what I have is -3 minus 5 squared plus 7 minus 3 squared. So I have -8 squared plus 4 squared. So that would be the square root of 64 plus 16, which would be the square root of 80. And 80 can be simplified by, so 80 divided by 16. So that would be 4 square root 5. So that's just the formula that you needed to know. For number 25, I'm going to try and squeeze in here too as well. Can you, and when you look at your book, I basically just made a line that would closely fit to all of those points. So these are the 2 points that I chose, and I want you to try and find those points before you actually do the problem. But we're going to do the slope. So m is equal to y1 minus y2, so 100 minus 500 over x1 minus x2, which would be 40 minus 70. So that would be negative 400 over negative 30. So I think that would just simplify to 40 over 3. Now that's our slope. So y equals 40 over 3 x plus b. I'm going to solve for plus b by plugging in one of my points. I'm going to plug in this point. So that would be 100 equals 40 over 3 times 40 plus b. So come up to here would be, making a common denominator would be 300 over 3 minus 1600 over 3. So b is actually going to be equal to negative 1300 over 3. So your answer is going to be w equals 40 over 3e minus 1300 over 3. For number 25. Okay, now looking at number 26. I'm going to start with adding the 2 fractions in the denominator, which would be this a squared plus 1 over a, making a common denominator of a. Everything else is going to stay the same. So that would be a cubed plus 1 over a. Now you're going to multiply this denominator by this numerator. Everything else is going to stay the same. So that turns into ab squared over a cubed plus 1. We need to make a common denominator down here. So I need to multiply this a squared times this denominator. So that would be ab still stays on top. But now that's going to be over a squared times a cubed plus 1 plus ab squared. When I distribute that, that's going to be ab over a to the 5th plus a squared plus ab squared. Oh, I forgot my a cubed plus 1 in the denominator. I'm so sorry. So this should be the a cubed plus 1 here. And now I'm just going to multiply this times the numerator. So I have ab times a cubed plus 1 over a to the 5th plus a to the 3rd plus a b squared. And what you should recognize is that, there's an a in each of those terms that we could cancel out. So that would mean this would go away. This would lower by a power, this would lower by a power, and this a would go away. So really I'm left with a cubed b plus b over a to the fourth plus a to the second plus b to the second. Now for number 27, I need you to just refer back to lesson 71. That's the problem I told you to write down, and that it's the same every time. So refer back to lesson 71. Now I'm going to take out my notes for lesson 105 to do numbers 28 and 29. And you should do the same, because remember there's like 4 steps that we have to know, or 5 steps, which turns into 6 steps that we have to know. So I'm going to start by writing this in descending order. So I have 2x squared plus 9x plus 9 equals 0. Step 1 is to multiply the first times the last term. So that would be 2 times 9, which is 18. Now I need to find 2 numbers that multiply to give me this number, but add up to give me this number. Obviously, it's not 2 plus 9 is not going to give me 9. And 18 times 1 is not going to do that. So my next option would be 6 times 3. It multiplies to give me 18 and adds up to give me 9. So these are going to be my 2 middle terms now. So that would become 2x squared plus 6x plus 3x plus 9 equals 0. We're going to separate these into 2 separate parentheses. So I have 2x squared plus 6x plus 3x plus 9. Now, what can I factor out of the first parenthesis? Well, both of those terms are divisible by x, but they're also divisible by 2. So that would be 2x, leaving me with x plus 3 in parentheses. In my second parenthesis, the only thing that divides both of those terms would be 3. And I would be left with x plus 3 in parentheses. So now for step 5, I'm going to factor out that x plus 3. So I'm going to have x plus 3 on the outside, which leaves me with 2x plus 3. And that's the factoring part. Now I actually have to solve. So I'm going to set x plus 3 equal to 0. And then 2x plus 3 equal to 0. When you move the 3 to the other side, it becomes negative. So you have 2x equals negative 3. So I have 2 answers. I'm going to have x is equal to negative 3 for the first one, and then negative 3 over 2 for the second one. Now looking at number 29, it's a very similar problem, but the first thing that you need to recognize is what can be factored out of all 3 of those terms. All 3 of those terms are divisible by 2, but they're also divisible by b. So I'm going to factor out a 2 and a b, leaving me with 3b squared plus 10b, and then plus 3. Now I'm going to multiply my first term times my last term. So that would be 3 times 3 gives me 9. Now I need to find what numbers multiply to give me 9, but add up to give me 10. And that would be 1 times 9, which adds up to 10. So these are going to be my 2 middle terms now. Don't forget your 2b on the outside though. So that would be 2b, 3b squared plus b plus 9b plus 3 equals 0. Now these 2 will form a parenthesis, and these 2 will form a parenthesis. So for step 4, I still have my 2b on the outside, but I have 3b squared plus b first, and plus 9b plus 3 second. Now you need to see what you can factor out of both of those parentheses And then the first one, the only thing you can factor out is a b. But that would leave me with 3b plus 1. In the second parenthesis, the only thing I can factor out is a 3 as well. So that would leave me with 3b plus 1. Now I want to factor out that 3b plus 1. So I have 2b on the outside. 3b plus 1 times b plus 3. You're going to set each of these equal to 0. That's why I've underlined them. And then that's how you're going to solve. So you have 2b is equal to 0. You have b plus 3 equals 0. And you have 3b plus 1 equals 0. When you divide both of these terms by 2, you would get b is equal to 0. When you move the 3 to the other side, you're going to get b is equal to negative 3. And for this last one, you have 3b plus 1 is equal to 0. So you're going to move the 1 to the other side, giving you 3b is equal to negative 1. And then you'd get b is equal to negative 1/3. And those would be your 3 answers. Now, lastly, we're going to look at number 30. So for number 30, we have find h plus p of negative 3, where h of x is equal to x squared. The domain is reals, and p of x is equal to x cubed. The domain is negative integers. So when you are asked to add these two together, h, p of negative 3, I'm going to take my h function, x squared, and add it to my p function, which is x cubed. Next, what I need to do is I need to check to see if negative 3 is contained within the domain of each of the individual functions. So is negative 3 a real number? It is a real number. Is negative 3 a negative integer? It actually is. So now what I'm going to do is I plug this negative 3 in, and that would give me negative 3 squared plus negative 3 cubed. So that would give me 9 minus 27, which gives me negative 18. And that would be your result.